Question 3. Find the optimal simple exponential smoothing model to predict sales for time period 2 to 16. Calculate MAD, MAPE, and MSE. First of all, let's look at a formula for simple exponential smoothing method. Y sub t plus 1 hat is equal to yt hat plus alpha times yt minus yt hat. Hat over here means forecast. Alright, let's see how this formula works. Suppose we want to make forecast for time period 1. So t plus 1 is equal to 1. That means what? T is equal to 0. So it's going to be equal to y0 hat plus alpha times y0 minus y0 hat. But where are we going to find y0 and y0 hat? No, we cannot. So the convention is we set the very first forecast to be equal to the actual sales of the very first time period. Okay, sometimes this is called initialization. Now let's turn our attention to time period 2. So we are looking for y2 hat. In that case, t plus 1 equals 2, so t will be equal to 1. So y2 hat will be equal to what? y1 hat right here plus alpha, once again let's use absolute cell reference, times the difference between y1 and y1 hat. Okay, return. What we have in this parenthesis is nothing but what? Forecast error from previous time period. So alpha is actually making an adjustment based on the previous forecast error. Now let's talk about alpha a little bit. Well, over here, once again, we randomly pick a number for alpha, 0.5 for convenience. In a few moments, like we did earlier, we're going to use solver to find the optimal value for alpha. And alpha is going to be a value between 0 and 1. Okay, and once we have the forecast, we can get the forecast error. You see over here, we start from time period 2 because for time period 1, we kind of cheated a little bit, right? So we make the very first forecast equal the actual sales of the first time period. So we start from time period 2 to calculate forecast error, absolute forecast error, and absolute percentage error. Last but not least, squared forecast error. Like we did earlier, we want to make sure those forecasts are going to be a integer. So we keep 0 decimal place. That will get the job done. And we're gonna do the same thing for the remaining 13 time periods. Here it is. Alright, no surprise, we're gonna calculate MAD, which is the average of all the absolute deviations. And MAPE is nothing but the average of all the APEs times 100. So here we get, on average, the forecast error is about 17.93% of actual sales. In the end, MSE is the average of all the squared forecast errors. Okay. Next, we're going to use solver again to find the optimal alpha value. Data, solver, objective H24, once again, we want to minimize it by what? By changing the alpha value, which is in cell L4. And what's the requirement on alpha? It's going to be a number less than or equal to 1. Here it is. And we also want to make sure alpha is also non-negative. Once again, we're going to choose GRG nonlinear method because MSE is mean squared errors. We have a square term over here, so we have to use nonlinear method. That's it. Let's go ahead and solve it. See what we find. The optimal alpha value turns out to be 0.36639. As a result, the optimal or the minimal MSE is going to be 76. And that's how the simple exponential smoothing method works. And that's how we can find the optimal alpha value to minimize MSE.